Okay, so in S1.2, the topic is the nuclear atom. This is the topic, and this topic is actually consists of four subtopics, which is very interesting. And IB always asks questions from here. The first is nuclear model of the atom. The second most important is subatomic particle, and the third is isotopes, and the last is interpreting mass spectrometry, or you can say mass spectra. This is a higher level portion, whereas these three topics are for SL level. So without wasting any time, let's continue with the nuclear atom, and we'll talk about the subatomic particles and how they help. So let's continue with the topic. So in the nuclear atom, let's discuss about what is subatomic particles, right? That's a major question. What are subatomic particles? So when we talk about subatomic particles, actually we have proton which is positively charged. We have neutron which is neutral. There is no charge on them. There is an electron which have a negatively charged, one unit of negative charge. So these particles are present in an atom, which makes the atom, right? So these subatomic particles are so small that it is not practical to measure their masses and charge using our normal conventional method. So instead, the masses and the charge of these particles are generally compared to each other, and that's why we call relative atomic mass and the relative atomic charge. So the term which I have used is relative charge and relative mass. So as we are not able to measure their mass and charge accurately, so we have used a relative method. Right? So these are not actual charge and masses, but rather charges and masses are particle relative to each other. So proton and the neutron have a very similar mass, right? So each is assigned as a relative mass 1, right? Electrons are 836 times smaller than the protons and the neutrons, and so their masses can be considered as negligible. So we can say negligible, right? Okay, so the relative mass and charge of the subatomical particles can also be written like this. So the relative mass of proton is 1, neutron is 1, electron is negligible. The charge is for proton plus 1, neutron there is a no charge, and for electron there is a minus 1. Now there is one exam tips here. So the charge of the single electron, let me write here. This is important. Charge of single electron is, you have to remember, First is minus because it is a negatively charged, so it's 1.602 into 10 to the power minus 19 coulomb, whereas the charge of a single proton is, we can say, with plus 1.602 into 10 to the power minus 19 coulomb. So, however, relative to each other, their charges are plus 1 and minus 1 respectively. So, these information can also be given in your data booklet, so we don't have to worry about it. But when we solve the questions, these values should be in the fingertip, right? So, let's go ahead with the further discussion. Now, now the question is where they are location, subatomic particle locations. Let's talk about where they are found. So, atom is very small. So, atom has a positively charged dense nucleus. So, we can say atom have positively charged dense nucleus, right? And the nucleus positively charged is due to, now when I'm saying it is positively charged, so this positively charged is due to proton. Fine. And as it is a dense, so dense because mass of the atom is concentrated to the nucleus. That's why it's dense. So mass of the atom is concentrated in the nucleus. That's why it's dense, because which contains all heaviest subatomical particles. So that's why the mass is confined here. The subatomic particles in the nucleus are generally the nucleons. So when we say about these are actually nucleons. That means contain proton and neutron. So these two particles are present in the atom. Now, when it comes to electrons, where these electrons are, so negatively charged, when I'm saying negatively charged, I'm talking about electrons. So electrons occupy space outside the nucleus, right? So they are actually moving in an orbit, right? And they have a very unique structure. Let me show it where it is. So let's say this is your nuclear particles, right? And these are the orbits, right? Right, there are various axes. Orbits are, this all are in x y z direction, so we are not going to align in 2D structure. So this is, let's say this is x-axis, this is y-axis, something is moving in the z-axis like a circle, and electrons are moving in each orbit, right? So what is this? This is orbit of electron, right? What is this? This is electron. What is this? This is nucleon, which have proton and neutron, right? So these atoms contains all the three subatomic particles, and the atom is neutrally neutral, is electrically neutral because the neutron and the electron charges are similar. Now, who holds all these? So, as we have seen that there is a negatively charged, so there is a force of attraction. We call them the electrostatic force of attraction. So, we can say the electrostatic force of attraction between positive nucleus and negative electron orbiting around it is what holds an atom together, right? So, in this way, the particles are held by the force of attraction, right? Now, let's discuss about some mathematical part of it, like how we can find out the electron, proton, and the neutron in any atom. So, let's take an example how to find the number of subatomic particles. So the atomic number, so there are some terms: atomic number, atomic mass, right? So atomic number is actually a proton number, right? So we can define it by saying the number of protons present inside the nucleus of an atom is atomic number, and this is represented by Z, right? So let's take an example. Something is written, let's say this is an atom, X atom. Something is written at the base, that Z is atomic number, or you can say number of proton. Something is written at the top. This is mass number. Now, when I'm saying mass number, this is a sum of proton and neutron number together, also called nucleon number, right? So we can say that A is equal to proton plus neutrons, and if you have to find out the number of neutrons, you can say neutrons number will be mass number, atomic number, E minus Z. In this way we can find out. Let's have some questions. Take an example that, let's say there is you have to determine the number of proton of the following atoms, right? Okay. Let's say first is carbon. So for carbon, it's a carbon atom. How to find? You have your data booklet, right? So you can check. Carbon atomic number is 6. This means that this is the atomic number. So that means 6 will be the atomic number is always equal to proton number, right? So I can say atomic number is equal to proton number. So its answer will be 6 in this case. Let's say if I am taking Mg2 plus, how to find the number of proton? So when I'm saying Mg2 plus, Mg atomic number is 12, right? So this means the number of proton in the nucleus is 12, right? So I can say number of proton is 12. Therefore, the number of proton is Mg2 plus will be also 12. Number of proton in Mg2 plus will be also 12, right? Let's say there is an unknown atom, and this unknown atom, let's say, is X, and the mass number is given. Mass number is, let's say, 63, and the neutron number is given 34. How to find? So you have to use the formula here. The formula is very simple. Number of proton equals to mass number minus number of neutrons, right? So you can calculate. It will be 63 minus 34, and we're getting 29. So if you will check your periodic table in the data booklet, you will find this is copper, right? Let's say there is a three isotopes are given. Find number of electron, proton, and neutrons present in carbon isotopes. So carbon, so there are two isotopes given in the question, C12 and C14. Now, with the help of periodic table, you can find out that the carbon atomic number is 6, right? So I can say for carbon 12, number of electron, number of proton, number of neutron, and for carbon 14, both have 6 atomic number. So whatever number of proton is atomic number, so I can write 6. The number of electrons is will be same because whatever number of electron is proton is there, the same number of electron will be there. So I will write 6 here, right? Now if you have to calculate the number of uh, neutrons, so we know the formula. So the number of neutron will be, let me write the formula here. With the help of this, we can find out, as we know that mass number is equal to proton plus neutron, right? And if to find neutrons, we can say mass number minus proton. So if I'm going to put this formula here, we'll get neutron number, mass number is 12 minus 6. This is 6. 14 minus 6, this is 8. So these are the number of neutrons. Easy to find out. With this, you will able to calculate the number of electron protons in an atom or in ion without any difficulty, and we'll do the next part of the topic in the next section. Thank you.